as u. So that's how we determine that if this is going to, suppose this is the angle 60 degrees, so it's going to be like this. And along these lines, u is equals to constant. Either u was 1 or u was 0, we don't know, but it was constant. Not it? Next comes to, is it clear how I explain this? Next come to the problem. Can I erase
Yes,
this?
yes is clear. The 1 over f dash u. That's the
Yeah. So
that's the slope.
yeah,
But
and the
I don't know how to relate it with you.
mm-hmm. Yes, say what are you saying?
I think I got it. Yeah, everything.
Okay, and the most important thing, when we are writing any single line, so there is a geometrical meaning. There is a geometrical meaning in the back of every line. Like there is a geometrical meaning before every line. Without geometry, I am not writing anything. So, firstly, you need to understand the geometry, and then you don't need to remember, oh, 1 over f dash, because sometimes it is not possible. What is f dash? F dash is in the break. So, you need to remind the geometry. And once you will get the geometry, in that case, you don't need to just memorize those things. You can articulate those things. You don't need to memorize. So there is a difference between articulation and memorization. So when you articulate something, so you have something which is running in the background of you. So this is the line I'm saying, so this is the line because this is happening in the background. So once you will articulate why I am writing 1 over f dash, so that is the problem, how it is solved. So let's solve the thing, let's solve the problem, the Berger equation with the, I got my curve, the graph. Yeah, so once you will solve this problem with the increasing initial data, you will get the smooth solution. You will get the smooth solution. So yesterday we solved this Berger equation with two kind of initial data. With two kind of initial data. Now the first thing is, what is the behavior of this flux function? The first thing which you need to remind yourself is the behavior of this flux function. So what is the behavior of this flux function? Is it convex or concave?
Convex.
Exactly. So this flux function is convex. Now we know the theory, we know the geometry of the theory, so we cannot write every time, so f dash, this is going to be a dash, we cannot write those things. So we need to keep in the mind that if the flux function is a convex flux function, then the smooth solution like the expansion wave or rarefaction wave or the discontinuous solution where the characteristic curves coincide, where the two characteristic curves coincide, will depend on the initial data. So f is a convex flux function. Now if the initial data is increasing, in that case no characteristic curves are going to coincide, rather than they will expand in the xt plane, they will expand in the xt plane. However, if so, this is the case of increasing. Now the initial data is decreasing, guys, decreasing. So in that case the slope is going to change. Firstly the slope will be higher, like the tan theta will be higher, and then the tan theta is going to decrease. So for sure they will coincide. So there are two conditions. This gives the arising of rarefaction wave and the R expansion wave. This is just a way to say this. and we call it the solution defines in the whole domain. The solution exists, a continuous solution exists. The second is a discontinuous solution. Why we call it discontinuous solution? Because it is a multi-valued solution. So the solution which is physically acceptable should be unique valued, but it is a multi-valued solution because along this characteristic u is constant and suppose u equals to 0. Along this characteristic u is constant and suppose u equals to 1. So at the point where two characteristics coincide, you are giving two solutions. Now which solution will be acceptable? So you are getting multi-valued solution. So that gives us a discontinuous solution, or you can say that the solution which has a jump, which is changing. So these two things. Now we can again solve the question just to see that, and then we are proceeding towards the entropy condition. And Camilo, did you make a notes from the yesterday class, like what I explained?
Sorry, can you repeat, please?
Did you make the notes from the yesterday two questions which I discussed?
But I have just one question about what is the meaning of the line of the curve that we compute that arise from the first discontinuity. What is the meaning of that line? Why we compute that line? Like that is my question.
Okay, so you are talking about this thing where this is the line where the first characteristic meets.
Yeah.
Okay, so let's solve the problem. I am going to again solve the problem, and then I will tell you why I am discussing the first line, that line. That is the important thing. Actually, I was about to ask you, would you please type the solution of the both equation in the detail and can share it to me? If you can. The same problem. Because I wanted to keep this. I just explain but never make it a very clear note. So this was the Burger equation, and the initial data for the compression wave was u, x and t equals to 0, basically u naught x. So we can see that the initial data is decreasing with time. Now our first aim is to find out the solution of this differential equation using this initial data, and then we will draw the curve and we find the discontinuity line and why I am taking that line. Okay. So if x is less than or equals to 0, x is less than or equals to 0, the solution is going to be 1. If x is greater than alpha, the solution is going to be 0 because u is constant along the characteristic dx over dt equals to f dash u is equals to u. Next, our aim is to discuss the solution between 0 to alpha. So between 0 to alpha, u naught x equals to 1 minus x alpha, or we can say that u naught xi equals to 1 minus xi over alpha. So dx over dt equals to u naught xi, or x equals to 1 minus xi over alpha into t plus another constant, say xi. Yeah. So x is equals to t plus xi minus 1 over 1 minus 1 over alpha. No, sorry.
So u of x comma t is going to be u naught of xi. Now keep the value of xi is 1 minus x minus t alpha over alpha minus t into 1 over alpha. So alpha and alpha will be cancelled out, and then alpha minus c minus x plus t over alpha minus c. So alpha minus x over alpha minus t. Or we can simply write it u x comma t is equals to x minus alpha over t minus alpha. Just taking minus sign common out from the numerator and denominator. So this is the solution in the reason this. Now, what is the condition which I need to impose on t? We know that t is greater than 0, but still we need to impose the condition on t. Now we can see that as x approaches to t, as x approaches to t, this becomes 1. This becomes 1. So just write the solution. 1, 0, x minus alpha over t minus alpha. We can see that earlier the initial condition was when t equals to 0, this is 1, so x is less than or equals to 0. Now what condition will be imposed on t? That is very important. So we can see that to make the solution continuous, as x approaches to t from the left, this becomes 1. Sorry, from the right this becomes 1, and from the left it is already 1, so this is less than or equals to t. So when x approaches to t from the left it is 1, and from when x approaches to t from the right it is 1, so it is continuous. Now the second case comes 0. The second case comes 0. So when x approaches to alpha, when x approaches to alpha, this becomes 0, and from the left, and when x approaches to alpha from the right it is 0, so x is greater than alpha. Still we are left with the condition on t. So here now we can see that t, here t, as t approaches to alpha, here t is greater than 0, as t approaches to alpha this becomes unbounded, this becomes unbounded, is not it? As t
Yeah.
approaches. So we need to put the condition t should be less than alpha, and t should be greater than 0 for all, because the alpha and 0 and alpha is small region, and after that, so this is the condition t is less than x, x is less than or equals to alpha. So this is defined. Now what will happen when t is greater than alpha? What will happen if t is greater than alpha?
So we'll just have positive.
Sorry.
We have that t minus alpha is greater than 0.
So in that case, that is the point to discuss. That is the point which we need to discuss. What will happen if t is greater than or equals to alpha? So here we can see that between 0 to alpha, this solution is defined, and besides that this solution is defined 1 and 0, so t, and that will also be coming, with the characteristic, that will also be here. We are unable to write because we are not drawing the characteristic. So let's draw the solution, and then I will tell you what will happen when t is greater than alpha or equals to alpha. Here you can see that this solution cannot be admissible when t is greater than or equals to alpha. So we can write 1, x is less than or equals to something. But how you will define what will be the value? So that is the most important thing which we need to discuss. So let's discuss that thing. I think that is also the question of Camilo, is it?
Mm. I'm not understanding why the yu is equal to 1 when x is less or equal to t.
So this is the solution. X is less than or equals to 0. So when t was 0, this was the initial condition. So t will be 1. In this case, t will be 1. But what will be the condition on t? That we also need to impose, because we are not putting any condition in general for t. T is defined on whole R plus. This was the initial condition when x is less than or equals to 0, just to make the initial datum continuous. X is less than or equals to 0, 1, and when x approaches to alpha, x approaches to 0, it again becomes 1, so it is continuous at 0. And when x approaches to alpha from the left, it becomes 1, and 1 minus 1 is 0, and this is defined at this right from 0. So it is continuous on 0 and alpha. So in the same way, our solution will also be continuous, like we are writing a continuous solution. It is not in our hand, the solution, the characteristic will coincide. But what is in our hand, we are going to do our best. We are going to write the best solution. So here when we are writing t, so what will be the condition on t here? We don't know that. So we comes to the solution in this region. So when we comes to this region, we get this solution. Now with this solution, you can see that as soon as x approaches to t from the right, as soon as x approaches to t, it becomes t minus alpha over t minus alpha when x approaches to t. And what does it becomes? 1. It means it is giving the solution 1. And what is the condition? We also have the solution on the left side of this curve. On the left side of this curve, we have the solution 1. Is not it? So to make it, if x is less than or equals to t, we have the solution 1, and t is less than x. So when x will approach to t, it will become 1. So the solution is continuous at x equals to t. So from where we kept this condition. And for this condition, we don't need to actually put any condition, because here we are not putting any condition on t. T is defined, x is less than or equals to t, and in the region t is lying between 0 to alpha, because 0 to alpha is a small strip on x-axis. 0 to alpha is a small interval on x-axis. So in this interval, the solution is defined in this way. What will happen? This is fine. X-axis is fine. On t-axis, we are able to define only from 0 to alpha. What will happen when t will go beyond alpha? We also need to discuss that, and then how we will discuss that. So for that, we are going to rely on our characteristic. So let's see what is happening in the characteristic. Is it clear how we are writing? So that is the most important thing. We are going to discuss the characteristic. So I am saying that when x is less than or equals to t, this is 1. It means dx over dt is u, that is 1. So dt over dx is 1 for x is less than or equals to t. Is not it? In the same way, dx over dt equals to u equals to 0 for x is greater than alpha. That is dt over dx is equals to infinite for x is greater than alpha. So when x is greater than alpha, the slope is infinite. It means tan theta is 90 degree. When x is less than or equals to t, theta is 45 degree. And when x approaches to alpha, t approaches to alpha, the solution is not defined. When x and t both approaches to alpha, the solution is not defined, and there the solution is not defined. It means the characteristic going to intersect at that point. So this is say your alpha when x is less than t, like this reason t is always positive, t is always positive. So x is less than or equals to t, it means we are plotting all the characteristic on the negative x-axis. X is less than or equals to t. So we are going to plot on the negative x-axis. And between, when t is lying between x and alpha, in that region the solution is that. So from this to this will be the curve. And they are going to intersect at the point alpha comma alpha. At the point alpha comma alpha, because at alpha comma alpha the solution becomes alpha minus alpha over alpha minus alpha. That becomes undefined. So if this is alpha, so here somehow here the solution is going to undefined somehow here. Now when x is greater than alpha, our characteristic is the slope of the characteristic is infinity, so theta is 90 degree. It means when x is greater than alpha, just after alpha, the characteristic is going to be this. Is it clear? And what is the solution here in this region? U equals to
0.
0.
You're
Now,
right.
I am saying that when x is less than or equals to t, theta is becoming 45 degree, and the first discontinuity is occurring at, because x is lying between t and alpha, and t can take maximum value alpha from the left. T can take maximum value alpha from the left. So the alpha comma alpha point will be the first point where it is going to be undefined. Alpha comma alpha will be the first point where this solution will be undefined. Is it? So the characteristic emanating from this line is going to intersect at this alpha comma alpha. Now the other characteristic can also intersect. These characteristic can also go beyond this line and can intersect. But we are very interested in the characteristic that is intersecting on the first point, that is intersecting on the very first point, the first time t equals to tc, that is basically the minimum of the time. So we are interested in the first point. This is the first point of interaction. Before that, the characteristic is not intersecting. This is the first point of intersection. Is it clear?
Yeah.
So that's why I was interested in that, because every time when we compute the critical time, we compute the minimum of that phi dash xi. So the first point of intersection, we are interested in the first point of intersection. And for this curve, just think that there is only one intersection, there is only one point of intersection, and then all the characteristic between these will meet at this point, and the u is defined here is 1, and what will be the value of u here? U will be x minus alpha over t minus alpha. Now, what will happen when t will be greater than alpha? So, we are interested in the case what will be the solution when t is above this line. We are interested in that one.
I have a question. How can you say that t is between 0 and alpha, and then x is between t and alpha?
X is between.
T and alpha.
Okay. So, was this line clear that x is less or equals to t? So, this is one.
yeah, I imagine the t equals to x. That is a it's a straight line.
Yeah. So when
So
x is
we're
equal to t is 1, so x is greater than t will be coming to the next part. We cannot make a gap now. If x is less than or equals to t, so 1. When x is greater than t, then this part comes. Now, how I am saying that this x should be less than or equals to alpha, so the next reason was that when x was approaching to alpha, the solution was becoming 0. And what is the solution on the right hand side? 0. So to make the solution continuous, we took the condition x is less than or equals to alpha in this region. So as soon as x approaches to alpha, it becomes.
yeah.
Now why I took this 0 t between 0 to alpha? So we know that t is always going to be positive. We need to define the upper limit, and we can see that as soon as t approaches to alpha, the solution becomes indefinite. The solution is indefinite, undefined. So that's why t is less than alpha. Now we are interested.
Now I understood. I actually think I'm going to like draw like the line t equals to x because that's where the solutions break from u equal to 1 to u equals to x minus alpha over t minus alpha. There where the solution
Yeah.
changes in the line t equals to x.
Yeah, the solution changes at line t equals to x. But since
Yes.
this is alpha is also defined, so we cannot simply say x equals to t. We need to find out that line because that line is passing through alpha comma alpha. Alpha comma alpha is the point of discontinuity. So that line is passing through. What will be the equation of that line? X equals to x of t. What will be the equation of that line? So the equation of that line will be dx over dt equals to x minus alpha over t minus alpha. And when you will solve this equation, you will be getting t plus alpha over 2. So this is the line x equals to t plus alpha over 2. And now, since this is the line, we are discussing about the first point of interaction, the first point of multi-valued solution. So we are not talking about the second point where the solution will be multi-valued. We are saying that now beyond this line, below this line, it has three solutions, but beyond this line, the solution is going to be this part, this characteristic, and this characteristic, because it is our assumption that we are not talking about the second point of interaction of the characteristic, because we cannot see it from here, but there might be more than one jump, there might be more than one multi-valued solution. So beyond this line, it means when x is less than or equals to t plus alpha by 2, the solution is 1, and when x is greater than t plus alpha by 2, the solution is 0, and this part is elapsed because this part converges to this point in this region. In this region. In this region, this part converges to the point alpha comma alpha. Is it clear now?
Yes.
Camilo?
Yes, it's clear.
Yeah. So, would you please do me a favor that you can write these things what I have explained in your, like what you have understood in your language, because even I don't have prepared a note, so I will say this thing because this was interesting. Okay. Next, since here we are clear about the things, and the assumption was that there is only one point of the interaction of the characteristic. So that's why we could say that. But it is not always the case. There might be more than one point of interaction, So here we are not discussing that thing. We are discussing that there is only one point of interaction, and that's why we were able to say that when t is greater than alpha, the solution is defined in this sense. Next, we come to this part. There might be more than one solution to a single differential equation. So to follow that part, I have already uploaded the notes. I think now you guys will be able to solve the assignment 3 and it would be much easier. Is it? Now, would you be able to solve the assignment 2, assignment 3? I think the assignment 3 is related to these two questions. Can you please open the assignment 2? Let me open it for all of you. Is it visible? My screen is visible.
Yeah.
So here I am giving this flux function where you can see that f double dash u is going to be minus 2, so less than 0. Now I am asking that solve this. I have already explained this traffic flow problem. So solve this traffic flow problem with piecewise constant initial data this. Now the flux function is convex. So when f will be a decreasing function, you are going to get a smooth solution. And when f will be an increasing function, then in that case the characteristic will coincide, just opposite to this problem. So you can take according to your own choice. First take ul equals to 1 by 2 and ur equals to 1. ul equals to 1 by 2 and ur equals to 1. So it is an increasing function. In that case, you will encounter a multi-valued solution, and the second you can choose ul equals to 1 and ur equals to 1 by 2. ur equals to 1 by 2. In that case, this is a decreasing function. ul is 1 and ur is 1 by 2. In that case, you will encounter a rare fraction wave, or you can say that a solution which exists for all the time t. So it is not that you are keeping just ul and ur. You have to choose one value of ul and ur, like 1 by 2 and 1, and then 1 and 1 by 2, and then discuss the same thing which I have explained for this problem. And I would suggest you just solve this today so that you will be able to ask me more questions if you have any. And the second problem, the second assignment 4 which I am going to give, I will change the time. So here I am giving you the conservation law, and this is the Increase-Burger equation. So sigma function of x square, I have made a mistake, so I have typed the sigma x. So this is the initial data. Now you can see that before x negative and after x it is positive. Now again you need to analyze whether it is increasing or decreasing, because you already know that this is a convex function and you have to find the explicit form of the solution. So here you can see that the initial data is not a constant, it is a variable function. So solve that and see, oh sorry, I'm not sharing my whole screen, just wait. I was thinking that I'm sharing the entire screen, sorry. So this is the fourth assignment which I am going to give you. Now here I am giving you the Invisit-Burger equation, and I am giving an initial data that is not a constant but that is depending on x. So using this initial data, you have to find out whether you are getting a smooth solution or non-smooth solution, and you have to write the explicit form of the solution with the drawing. In the second case, I am giving you smooth initial data, and you have to prove that whether the solution exists for all the time or not. If the solution exists for all the time, then you have to find out the solution. The next, sorry, I'm not getting little more. No, no, I am going to increase this time for the assignment 4. Assignment 4, the submission of the assignment 4 will be, I think, 13th of September. Yeah, you have every time when I am giving you an assignment, I give 1 week time, because I know that 1 week time you should have 1 week time. That's why when I created assignment 3, so I make the submission at 11th September. For assignment 4, I am going to make it. Let me check the calendar. So by today I will assign the assignment 4, and the date will be, what is today? Today is 5th of September. So the assignment 4 submission will be 13th of September. That assignment has only one question, so this assignment will have 3 questions, and still I was preparing it. So it will have 3 questions, and all the 3 questions are based on the problem which we are discussing this week, like the last week and the entropy condition. So this will be the last assignment of this unit, and on the 18th of September, I am going to take your exam. That will be from only 2 units, from unit 1 and unit 2.
So the exam will be on 10th of September.
Sorry?
The exam will be 18th of September.
18th of September, yeah. The exam, like I was asking for the date, and I asked to choose 2 dates. One was 13th September, I think 11th September, and another was 18th September. So I choose to take the exam on the 18th of September, because you will start your unit 2, and then you will have enough time to revise unit 1, and I will start unit 3 the next week, and you will have enough time to revise your unit 1 and unit 2, and meanwhile you can discuss me more questions if you have any. Like, I have tried my best to explain all the things which is in your syllabus, and I have given a number of questions. I have explained the sufficient number of questions and each geometry. So I am expecting the same thing from you, that you will be reading those things, and then you are going to ask me questions, and you may read the book of L.C. Evans. I will announce about the exam today in the class. If for the assignment 4 you want more time, then you can tell me. I will increase the date. You want more time for assignment 4?
Yes, please.
Camilo, Roberto, Yvonne, please suggest me a time. What I should keep for the submission of assignment 4? I was asking that if you want more time for assignment number 4, then I can increase the submission date. But you need to suggest me what time I should keep it. What time? So, anyone suggesting Camilo what time I should keep it, what date I should keep it for submission? But I don't want to be late from that date.
Maybe 15th of September.
Okay, so I let me keep the time 15th of September because I want you take enough time to solve your assignment. But please do solve on the time and ask me a number of questions. I am more than happy when you ask me your doubts. So I have changed its date to 15th of September. Okay. So I will upload the assignment by today only. Assignment 4. I already uploaded assignment 3rd has only one question and I think you will be able to solve by today. So assignment 4 has 3 questions and all the 3 questions are like research problem and very easier research problem the people has done in their 90s 1967, but it is very interesting because this time we are solving a research problem, we are discussing a research problem. So if you are understanding this geometry then you are going to solve that question very easily. So consider the Burger equation, this, and if this Burger equation has an increasing initial data, then what was the solution of this Burger equation? We already have computed the solution. The solution which we computed, that was, let me write, that was 0 when x is less than or equals to 0, x by t when x is lying between, and 1 when x is greater than t. So this was the solution. This was the solution, and according to that, your graph was this. Because this was an expansion wave. So this was the line x equals to t that passed through the origin, and the curve, this is equals to u equals to x by t, and this was 0 0 0 0 and this was okay. So this was the solution and this was the graph we already have discussed in the detail. Next I am saying that this is the solution which you have determined with the help of the method of characteristic. Would you please check? I am saying that this is also the solution. Would you please check whether this is a solution or not? To check whether this is a weak solution or not, to check you have to check that it should satisfy the initial data and it should satisfy the differential equation. Would you please check and tell me whether this is a solution or not?
The red one?
The red one, yeah. Because we are going to discuss about the physically relevant solution. I am saying that this is a weak solution of this differential equation, but you need to check and tell me whether this is satisfying the initial data or not. Initial data and equation. If you are unable to do that, then let me check it.
But beta is equals to 1, or what is the value for beta?
Sorry.
What is the value for beta? An arbitrary value?
Beta?
Sí.
Beta can be any value. Beta can be any value. Okay, just let me explain.
Yeah, it satisfies.
Yeah, just
satisfies.
let me explain it to you. If you are keeping t equals to 0, just try to understand. So t equals to 0, this value becomes 0 and this value becomes 0. This is ellipse. 0 elapse. So 0 when x is less than or equals to 0 and 1 when x is greater than 0, because when you will be keeping t equals to 0, this is the value at 0. So that is not going to make any change. Okay? So you are getting the initial data, is it? Now, when x is less than or equals to beta t over 2, in that case ut is 0 and ux is 0. So when you are using this value of ut and ux in the differential equation, then it is going to satisfy 0 plus 0 u into 0 equals to 0. In the same way, when x is greater than beta plus 1 t by 2, so u is 1. What will be the value ut? That will be 1. What will be the value ux? That will be 1 and u is 1. So 0 plus 1 into 0 equals to 0. That is also satisfying. The next condition comes in between these strip beta t over t 2 and beta plus 1 t over 2. In between these two strips, like suppose beta is any positive value, so beta t over 2 is going to pass from here and beta plus 1 t over 2, it is going to be from here. In between these two strips, the solution is beta. U is beta. So U is beta, it means ut is a constant 0 and ux is also 0. So the solution will be 0 plus u, that is beta, 0 equals to 0. Again it is satisfied. It means this solution is satisfying your equation for all the range, and this solution is also giving you the initial data at t equals to 0. So this is a weak solution of the given Burger equation. This is the weak solution of the given Burger equation because you are checking the solution piecewise. In this piece, it is satisfying. In this piece, it is satisfying. In this piece, it is satisfying. So, is it a weak solution of the given Burger equation or not? Are you able to say that this is a
We
solution?
need to check. We need to check the discontinuity.
No, this is continuous at beta t over 2 and beta plus 1 t over 2 because the left hand limit and the right hand limit is going to be same. So, and even you don't need to check the continuity, just rely on the thing. I am not talking about the continuity. I am talking about the weak solution. Sorry, I haven't checked the continuity. I am talking about the weak solution. So what is the meaning of the weak solution? The solution is defined piecewise. So whether it is piecewise continuous or not, don't talk about the continuity in the global. Piecewise continuous or not. Is it piecewise continuous or not?
Yeah, I think so.
So it is a piecewise continuous, it is satisfying the given partial differential equation and it is also giving the initial data at t equals to 0. It means this is a weak solution. I am not saying it is a global solution which is existing for all the time and it is continuous and all the time. I am saying it is a weak solution. It means the solution given by this equation is a weak solution of the given partial differential equation. But whether it is physically acceptable solution or not, we don't know. So you will change the beta. Beta
But
is
it makes a sudden jump from 0 to beta.
that's why I'm talking about the piecewise solution. That's why I'm saying
It's
piece.
not continuous.
That's why I'm saying it is a weak solution. I'm not saying the solution is smooth. I'm talking about the weak solution, whether it is a weak solution or not. Now you know the concept of the weak solution. The solution is piecewise continuous.
Um, I don't I don't think 0 to beta is piecewise continuity.
Piecewise continuous means in this interval it is continuous, in the second interval it is continuous, in the third interval continuous, but in their union I cannot talk about the continuity. What is the did you forget about the definition of the weak solution?
Huh?
Did you guys forget about the definition of the weak solution?
I think I got to that.
Okay, so whether can I say it is a weak solution of the given PDE or not? Can I say that this is a weak solution of the given PDE?
Yeah, it's a solution and it's piecewise continuous.
Yeah, so that is the definition of the weak solution. Huh? So that's why can we say that this is a weak solution of the given PDE?
Yes.
Next, can you check that this is a weak solution of the given PDE or not? Please check and tell me.
I think that yes, because it satisfies the PDE. It's like continuous every piecewise continuous.
Yeah, so is it a weak solution or not?
Yes, yes.
Camilo?
Yeah.
Now we can see that we have derived a solution of the given partial differential equation, and I think I erased that solution. X over t 0 and 1. This was the solution of the given partial differential equation that we derived using the method of characteristic. On the other hand, we are able to write the solution of this given partial differential equation. That is a weak solution of the given partial differential equation. It means this is a conservation law with convex flux function, and its initial datum is also monotonically increasing, but we are able to write more than one solution, and for sure they are not but they are weak solutions. So how we will optimize that solution, how we will single out unique solution, which one is the physically relevant solution, which one is the physically relevant solution. So that is the point, physically relevant solution. So author named Lex came and he said, okay, so let me give a criteria that will identify the unique solution, that will identify the unique weak solution, and the criteria was ULT is greater than the velocity, shock velocity. You already know, you can compute S equals to jump in Fu and jump in U. So ULT is greater than S is greater than URT. So I am stopping this class here, but for sure tomorrow we can talk. Yeah, so I need to go for a meeting in 10 minutes. So I am stopping this class. Tomorrow we can go 10 minutes. Yeah, you want to ask something, Camilo?
No.
Okay, so just work on the problem and please solve the traffic flow problem. Please, I would request you. You have 20 minutes. You can solve it now so that we can go over the your doubts, and if you are getting any kind of difficulty, then we can talk about that tomorrow. So please solve that, and we are going to complete this entropy condition tomorrow, and we will talk about the Hamilton-Jacobi equation and Eikonel equation. So that is the end of this topic. That is the end of this unit. And did you guys enjoy this unit? Like, was it good or not? Like, geometrically, and it was representing a number of physical phenomena. So, did you enjoy this unit or not? Or it
I
was.
think, I think
Yeah.
in the when I need to study more to like realize how incredible like these results are.
So, I wanted to ask you, which class
But
is
yes,
better, ODE or PDE?
no, I think you're like an excellent teacher.
No, no, I'm
Everything is clear.
talking
Everything is clear.
I'm talking about the topic because I did not like
Yeah,
ODE.
yeah, yeah.
Which one is
It's
better, ODE or PDE for all of you?
I
Okay.
think that PD has more like
Yeah, like
more
I
fun.
also like the PDE because it has a number of physical phenomena, and here we are not proving a theorem, rather than we are going to the geometry and we are writing everything to the geometry. So I love to study this PDE, so that's what I was asking. Which one is better for you, ODE or PD? Okay, so this is the thing which you can revise, and tomorrow most probably the class will be little longer, and I would prefer to finish the thing and then we can discuss over the next unit in the next week. Okay, so bye. Bye.
Bye.